So, good evening, everyone. Again, we will in the fourth class of FET, that is in the module of part programming of CNC machines. So here we have already discussed in the last three classes that how the motion comments can be given, how the different vocabularies can be specified in the APT. Now we will discuss about some examples. Okay, so these examples we have chosen from the one very good book, the MP Groover. The name of the group is Automation Production System Computer. You can see this. So these type of problems is there. So we'll talk about this type of problems. Now these are the mentioned things. So what are these type of questions may come in your semester. So you please try to understand. So feed rate we have already given. If feed rate is not given in the questions paper, you can choose at your own. Spindle speed, this is already given. Coolant is to be flash the chips. This is the just information purpose. The cutter diameter 5 inch, 0.5 inch you already mentioned, and tool home position, that is P targ. I have already told that there is a some go to points is there. Before that, P targ. P targ is the comments or vocabulary of APT, that is mentioning from where the tool should start its motion, that is P targ, and this is the home position. So here P targ is mentioned 0, -1, 0, x coordinate, y coordinate, and z coordinate. Okay, so how you will do this? This is the milling operation actually, or you can say this is a profiling. So before that, in the CNC, we have already told you, you need not to specify the cutter radius compensation. Okay, but here, because it will be understood by the MCU, modern MCU systems, it will be understood. But here, if such examples will be there, you have to specify the tool path considering the cutter radius compensation. So if we have already taken the tool that is 0.5 inches, this is the just half of the diameter or 0.25 millimeter. According to this, we have to specify one. That means if this is the actual part you are want to produce, so actual tool path will be 0.25 inch of offset, nothing more than that. Okay, you need not to worry about it. It is very simple. You just take a tool path which is just offset of 0.25 inch. Now these type of things you have to specify. What are the important things you need to specify? These are the important things. So every this P1, P2, P3, if this type of, actually in G code and M code CNC programming, this coordinate point are given, but here it is not important. Why this is not important? Because you can point here, suppose this is a 1 point, you can specify this as a P1. Here is 1 point, so you can specify as P2. So, and this point, this coordinate point, you can choose. If this type of drawing is there, it must be specified some points or coordinate points. If it will not there, you can imagine at your own. Okay, so here I will just give you the example. So these are the important points. So P0, P1, P2, P3, P4, these are the important points. P1 here, P2, P3, this is the center point of this circle, P4 and P5. Okay, this is the last point. Sorry, P4 is the last point. So then L1 is important. This is the L1 and circle 1, L2, L3, PL1. So why PL1 is also important here? Because P1, P2, P3 is what is this indicating? Is indicating the actually drive surface or the part surface of the cutting position where the machining can be carried out. So that's why you need to specify the plane also. So how will specify the point 0? I have already told you that point slash 0 -1 0. So this P1 P0 coordinate where the point will be specified already in the questions. You can see that the starting point 0 -1 0. So this is the 0 -1 0. This is the P targ point. P0 is the 0 minus 1 0. Now P1 is the starting point. So this is the P target point and this is the starting point P1. This is the 0 0 0. After that, if this dimension will be given to you, this dimension, this radius and this dimension, according to this you can also calculate the coordinate point. Otherwise, if the coordinate point is given, you can also calculate the length, or you can also calculate the coordinate point. Whatever is suitable for you, you can do that. So here we have already taken that it's a dimension of 6 millimeter. That's why P2, it's actually on the 6 millimeter away from the x-axis. The direction will not change. That's why 6.00 and 0. P3.610, because P3 point is here. It's a center position, and it will be it must be given. Okay, so 6.10. So now here you just understand how the points can be specified for a given example, how the line can be specified. Now look at the figure that L1 is the line slash P1 P2, and P1 P2 already specified previously where the coordinate points are specified. So coordinate points already will be mentioned in the questions paper. Otherwise, this if this type of things will be mentioned, here you can see these graphs are already mentioned. Okay, so with these graphs you can easily take the coordinate points. So it's a 6. This is the you can take the this. Okay, so this is actually 2. Actually, this is 2. So the radius will be on 1. Okay, like this you can calculate everything here. It should be mentioned. Either this type of graphs will be there where the coordinate points are mentioned. Otherwise, in the particular points, the coordinate point will be mentioned. Otherwise, this dimension also needs to be mentioned. Otherwise, you cannot specify the exact point where the tool should move. So in here, actually, the important points, lines, and plane will specify. Then we will move to the motion comments and auxiliary comments. Okay, so this is the spindle. I have already told. So spindle will rotating with the 573 RPM. That is already mentioned in the questions paper. Feed rate 5.39 is the feed rate inch per minute. Coolant on. This is the another syntax. Coolant before starting the exam point. Before starting the machining operation, you need to start the coolant as like the CNC program. So from P0, the starting point is the P0. This is the target point. From P0, go past L3 to PL1 to L1. Okay. So now you will understand. Go past. So past means I have already told, if this is the check surface, past means tools will be touching the last position of the tool will be touching this surface. So go past L3. So where is our my L3? So this is the starting point, my tool. It will be moving, and this is the L3 point, and this is the nothing but the check surface. So the movement will stop when the tool will touch this check surface. Okay, so if it is not passed, it will on, then it will be tool position will be like this, and it will be if 2, it will be like this, and it will be on, it will be just center position. Okay, so these 3 things I have already mentioned. So here I need to cut the total part. If this is the part I need to be cut. Okay, so you need to specify or you need to move the tool beyond this check surface. If this is the check surface where I tool to move, so beyond the check surface I need to move the tool. So that's why tool needs to be moved beyond the check surface. That's why past comments needs to be specified. So past L2, that means it will be L3. So it will be cutting the exact position to PL1. So PL1 is nothing but it's a drive surface. You need to mention this to L1. Okay, so again L1 is this one. So this is the initialization, contouring motion, drive part, and the check surface. So you initially you just specify what is your check surface, that is L3, what is your drive surface, and what is your part surface, and what is your drive surface. So L1 is your drive surface. The tool will moving like this. So L1 is the drive surface you are mentioning here. PL1 is the part surface. On PL, actually this plane, that cutter, bottom of the cutter is moving. like this. So that's why PL1 needs to specify. So initially you need to specify these things, then you have to mention start the operation, go up L3. So now I am starting the my cutting actually. So I have already mentioned spindle, feed rate, coolant, from where it will start its motion, and different surfaces, that is the check surface, part surface, and drive surfaces. Three different surfaces we have already specified. Now we are starting our cutting. So initially you just pretend that you will be on the tool. So go up L3, go up slash L3. So you are moving upward direction. If you are sitting on the tool, as per you, you are moving upward. That's why go up slash L3. So along the L3 you are moving, so slash L3. Then you have to move beyond the L2. So this is L2, beyond the L2, because you need to cut the total entire position. That's why it will be moved like this past L2. So then if your now your cutting position is like this, here current tool position is here. Now you have to mention that you have to go rightward. Now you are sitting over here, now it is your right side. Okay, now you are moving along L2, so you have to mention go right slash L2. Along the L2 the tool is moving, then tan to where it will move, up to where it will move, it will be just tangent to the C1. When the tangent will come, it will stop its movement with these comments. Go right slash L to tan to C1. Now you have to go again forward. Okay, again forward. You have to move along the C1. That's why go forward. Then C1. Okay, then along the C1, your cutter will move. This is the C1. Then on where the on movement will be there, because the center position will touches the check surfaces. Check surface is, what is that? Check surface is nothing but where the tool stops its movements. Okay, so on means I have already given you, this is past, this is on, and if that just it will be touches the tool, it is 2. Okay, the 3 different comments will be there. So if the cutter will be here, it should be on. So go forward along C1 on P2. So when P2 is coming, then it will stop its movement. So this is the P2 point. So everything C1, P2, L2, everything you have mentioned earlier. Now here from here to here you have to move, then you have to go forward. Here you have to go forward because you are sitting over here and your front portion. So now your movement will be like this and you will be moving forward. So forward moving along the L1 line. So you are writing L1 past L3. Why past comments is there? Because you need to cut this entire position. So because this is your part you want to remove, you want to make this is your part, and this is dotted line your tool position, tool movement, or you can say the cutter position. So if you want to make cut entire positions, so past movement will be there. What will be the problem if I will make on or 2? Because this extra amount of material will not be cut. If on motion will be there, if you mention on, okay, so L3, this is your check surface where the points will be there. When it will be touches the tool, it will stop. If two comments will be there. If on comments will be there, when the center positions will be coinciding, then it will stop its movement. And when the past comments will be there, then when it is cross the check surface, then it will stop its movement. So it is necessary to cut the entire positions. You have to cut the entire position. That's why past movement is necessary. Okay. So depending on the situation, you are specifying to, on, and past. Okay, so here you need to understand. Now rapidly move cutter position from where it will start, then go to P0, rapidly go to the P0 position because you have done what you want to cut, then coolant off, then finish. These types of things you have to mention. Now one examples of drilling operations. Okay, so for drilling and milling, the simple geometry we have taken for same thing. So we will specify here the different types of things we have specified. In the last examples, we have specified that some graphs, okay, where coordinates are specified. But here we have already mentioned, this is also taken from the book. It is also mentioned the exactly coordinate point. So it is very much simple for you. And if questions will come from APT, this type of things will be there, the drawing will be there, and this type of point will also be mentioned. If drilling will be there, this thickness of the workpiece needs to be mentioned, and this is nothing but the 10 mm. So what is the questions given? Tool diameter 7 mm, tool number is 1, the RPM is the number, VF, this is the cutting velocity, 0.05 millimeter per minute, is given for drilling operation. And for milling operation, N mill cutter dimension of 20 mm, tool number is 2, N is the 1000 RPM, VF is the 50. And we have this is also mentioned that starting point or P targ is 0010. So 0010 is the starting point from where the tool is starts its movement. So now again you can see that that you have to mention every points, important points. Okay, so where are the important points? P1, you need to specify what is the coordinate point. P2, P3, P4, P5, P6, every points you need to specify. L1, L2, L3, L4, these are the 4 lines. You can see that these are the L1, L2, L3, L4, and one circle is there. For that you have to specify the circle also. And every this P4, this also every points we have already in the questions paper, the coordinate points are given. So it will be not be very difficult for you to make these type of things. Okay, P1 is you know all the coordinate point, so you have already mentioned. So before that you have to part number, drilling and milling, you can specify. This is for your understanding purpose, it's not mandatory, but this is mandatory. Units mm. Okay, so as like CNC, we know G21 or G20 you need to mention before starting the operation. Here also units needs to be mentioned, otherwise it will be not understood by MCU that whether the every coordinate point is in the millimeter or inch. So cutter position, in the last examples you can see that units we have already given in inch. Okay, here units in millimeter, cutter dimension we have already specified in the question paper, it is specified is 20 mm. The P targ point you need to specify, then important P point and line you need to specify, and another important thing need to specify where the operation is done, machining operation is done. This is nothing but one plane, sorry, plane, and P1, P2, P3 is the 3 points. You have already understood that how you will specify one plane, you need to mention and any 3 points in the plane. So P1, P2, P3, you can take this type of things, and here the machining operation can be done. This you have to specify. This is your part surface basically. Now this is for example for milling operation. I will start the milling operation. So remark, start milling operation. So remark is for your understanding purpose. So from P targ, load tool. So load tool is the M06 like comment. A load 2 means you are specifying that 02. So from where 02 is coming? So from here tool number you can see that for milling operation tool number is 2. If this is specified in the questions paper, you need to specify load tool and /02. So if this is not specified in the questions paper, then you can write anything or you cannot write at all. Okay, so now spindle you need to on the spindle with 1000 RPM. This is also specified in the questions paper. Feed rate is also specified, IPM 50. Okay, so coolant, now the coolant will be on and it will be flat because the operation is starting. Now this type of movement motion commands can be specified. So go /2 L1, 2 PL1, 2 L4. So these 3 things, L1 is nothing but your drive surface, PL1 is your part surface, and L4 where the tool should stop, this is your check surface. So that's why these things you need to specify as like the previous case. Now you start the motion command. So go right along the L1. So here the movement will be like this. So this is your starting point, you are moving like this. So go right along the L1 past L2. So you need to cut entire material, so you need to take the cutter here. That's why the past comments can be specified. Then if you are here sitting on the this is your left side. Okay, So this is your left side. So now your cutter position should move here. So how the comments will be given? Go left slash L2. It will be go around L2 10 to C1. When the cutter positions or cutter will stop, when it will touches the C1, it will stop its movement. Now it will be move forward, C1. Along the C1 it will move forward, then past L3. When it will be stopped, when L3 will be, so this is your now check surface. When it will be stops, when the cutter is here. Okay, so L3 is the this type of things past L4. Now your cutter position will be like this. Okay, so go forward L3. So it is be along L3 and it will be stops when it will be stops the L4 or past the L4. So that's why past L4. Go left again. You have to move like in this direction. So again go left. This is your left side because you are sitting on the tool. It's your left side. Along the L4 you are moving. So go left slash L4 past L1. When it will stop its movement, now it will be your check surface. When the cutter positions is in like this, if this is your extended version of L4, when it will be stops, when it will be just cross the L4 past L1. This is your now check surface. When it will past L1, the tool is stops its movement. Now you have already cut this total entire thing. Okay, now rapidly go to P-Turk, initial positions, then spindle off, coolant off, and finish. This is your milling operation. Now I will give another example of the drilling operation. Same remark, start drilling operation, rapidly go to the P-Turk position initially, target position. Okay, P-Turk already mentioned. Now spindle off, coolant off if it is already on. If it is already, if you are starting from the milling operation, then it will be stopped. Otherwise you need not mention these things. Coolant already off and already on, you understand, you have to take that one. Now load tool 1, because we have already specified in the questions paper that in the drilling tool is in the 1. So rapidly go to P5. So rapidly go to P5. So now where is the P5? So this is the P5 because we have already produced these things. This part we have already manufactured in the milling operation. Okay, now only drilling operation you need to understand, need to manufacture or need to fabricate. So for that point, from initial point, rapidly you will move P5. Why rapidly? Because P5 point you will specify, P5 point you will just see over here. We have all overlooked that P point, every points P1, P2, P3, P4 is Z direction is -10. If this is 0, this is -10. It's the thickness of the workpiece. But here P4, P5, P6, P7, sorry, P5, P6, P7 and P8. These four are the four places where my drilling operation will be taking place. That's why we have specified the Z direction above the surface, 10 millimeter above the surface from the 0, 0. So if this is positive Z, that means my tool positions is somewhere like this. So P5, P6, P7 and P8 for drilling operation, you have already specified that the positions which is above the part surface. So actually the part surface where the milling operation can be done, which is the bottom portion of the workpiece, that is -10, the thickness of the workpiece. That's why milling operation can be done like this. 10 grooves can be done with the thickness of 10 millimeter. That's why it's a -10 can be used. And here these 4 drilling operation can be done. Now I will make the point. How you will specify? Now you have understood why I will moving the tool rapidly. Okay, because here nothing will be worried because we have already taken the point above the workpiece. We have already taken the tool above the workpiece. So we can rapidly we can move the tool. So rapid go to P5. So rapidly it has moved to P5 positions. Now start the coolant operation flood, because drilling operation will be done for the first time. That's why flood coolant will be done. Now start the spindle operation. Feed rate will be done. It is already given in the question paper. And go delta. Now one interesting thing is that go delta point is there. I have already specified when go to and go delta point. When I have specified, then I have told you that for the drilling purpose, go delta point is generally used. Go delta means from, this is like the incremental position. Now from it is above 10 millimeter. Okay, so above 10 millimeter from the surface of the workpiece. Now you need to drill the total, this is 10 millimeter, and this is the thickness of the workpiece is also 10 millimeter. Then you need to move the tool 20 millimeter. So that's why we have given go delta slash 0020. X and Y coordinate, it will not move because it has already moved to the P5 point. Now I will starting the drilling operation and it will move to the minus 20. That will just, it will be done the drilling operation. Now go delta, it will be again move the exact actual position, the where it will be starts its drilling operation, again plus 20. Then rapidly, because it is above the surface, rapidly you can move to the another point P6 for drilling operation. Then same type of movement you can do. Go delta, again minus 20, go delta, again plus 20, it will move. Then again you have to repeat for the P7 and P8. Just go delta minus 20 plus 20, rapidly go to P8, feed rate, and you have to mention these things you can omit because you have already mentioned early. Go delta again 20. So first of all, milling operation has already, you have cut the thing in the minus 10. This is the minus 10 thickness of the workpiece. Now you have already done the drilling operations also. Now rapidly go to the P-targ, where the starting position of the tool, spindle off, coolant off, finish. So with this, we have given the two types of example, and this is the very basic examples of drilling and milling operation which can be done. The APT or automatic programming tooling, this can also be done by CNC also. So these are the two things. With this, we will conclude these sessions. And sorry, if you have any query, please ask.